Hello, magnificent mathematicians. Welcome to our channel. I am your mobile math mom, and for those of you who are new to the channel, please hit that subscribe button and hit the notification bell so that you're aware when we upload new content. For those of you who are returning, welcome back. I am again your mobile math mom, and this is the channel where you receive education, inspiration, and information. Before we get started with the content, I always start with your affirmation, and I want you to say it to yourself. So everywhere that there's a you need to say I. So I'm going to speak this to you. You are fearfully and wonderfully made. The mold was broken when you were created. There's nothing you can't conquer or achieve if you believe. You are purposeful, powerful, and absolutely prosperous. You are dressed for success and destined to progress. Now give yourself a pat on the back. You got this, and we're going to tackle this content. Let's get started. So for today's lesson, we are going to learn how to factor trinomials step by step. And one of the methods that we're going to use is a method called slip and slide. So I want you to just hold tight. Don't get overwhelmed. What you need is your calculator. So go ahead and get your calculator, and we're going to go ahead and get started. All right, so the first thing that I want you to take notice of is that this is a trinomial. All right, so this is a trinomial of degree, hold on. This is a trinomial of degree 2. And the reason why this is a trinomial of degree 2 is because the leading term has an exponent of 2. All right, so we're going to, let me go ahead and erase this real quick. All right, so the first thing I want you to do is to recognize that a trinomial is going to factor into two binomials, right? So I'm going to go ahead and make my parentheses first. Now, I need to look at my leading coefficient. In this case, this leading coefficient is a 1. Now, the reason why I'm going to teach you the slip and slide method when factoring trinomials is because it works every time. All right, so let's take a look. The very first thing I need to do is I need to take this first coefficient and multiply it times the last term, which is the constant. Now make sure that your trinomial is in descending order. That means that the very first term needs to be your leading term with your highest exponential power. The second one needs to be the next one down, and then the last term needs to be your constant. Okay, all right, so I'm going to multiply the first term times the first coefficient times the last term, which is 1 times 7. That's going to give me 7. So I'm going to do a rewrite. Let me just erase this really quickly, and I'm going to rewrite this polynomial, and it's going to be b squared plus 8b plus 7, because 7 times 1 is 7. Now you recognize that nothing has changed from the original problem, but bear with me, there's a method to the madness. All right, so now I need to write down my parentheses. I know that my b factors into b times b, right? Now I need to look at my last sign, and that sign, if it is a plus, that is a result of multiplication. And I know that whenever I multiply two integers together that are the same sign, I'm going to get a plus. But then simultaneously, I also have to look at the middle sign, and that is a plus. So at the same time, where my signs are the same, I need to determine what those two signs are going to be. And this sign tells me that both of my signs are going to be plus or positive. All right. Now, don't get caught up. Just wait. Now on the side, what I need to do is I need to write down all of my factors of 7. So this is going to be factors of 7, right? Starting with 1. So 1 times 7. Is there a 2 times something that gives me 7? No. Is there a 3 times something that gives me 7? No. So then I go all the way down and I recognize that I have 7 times 1 is my other factor, or my other factors, and so I'm done. Now, what I also need to do is I need to figure out what two numbers when I multiply together will give me 7, but when I add them up, I will get 8. Now remember, my signs are both positive, so I'm going to put a plus on both of these. Right? So I have 1 plus 7 gives me 7. 7 plus 1, I'm sorry, gives me 8. My bad. 7 plus 1 gives me 8. Right? So either combination works. Because of the commutative property, I can put 7 and 1 here, and it doesn't matter. I can check my answer. Now let me show you something about slip and slide. I need to take my coefficient that was here and divide each one of my constants by that coefficient. Okay? When I do that, I have to simplify. 7 over 1 simplifies to 7, so I ended up with b plus 7. And then here, 1 divided by 1 gives me 1, so I ended up with b plus 1. This is my final answer. I can check that answer by going ahead and multiplying it out using FOIL, but I'm not going to do that. All right, let's check the next one. I know you say, okay, well, this looks really, really easy. And it is. All right, let's check the next one. All right, this is a trinomial. It is in descending order. And I want to make sure that I make a note of my coefficient, my leading coefficient. My leading coefficient is 1. So I'm going to multiply this first coefficient times this last constant. Rewrite my problem, n squared minus 11n plus 10, right? Now I know that I'm going to have two binomials, so I'm going to write my parentheses. I'm going to factor my n squared, that's n and n. And now I have a little dilemma, but it's not going to be too major. Watch this. This tells me that my signs are going to be the same. I need to know what those signs are, right? If they're both the same and this sign is minus, then I know both of my signs are going to be a minus. If this is a positive, that tells me my signs are going to be the same because that's the result of multiplication. This is always going to tell me the sign of my biggest number, but if my signs are the same in front of the 10, then I know that my signs are going to be minus, right? Now, over here, I need to write down my factors of 10, right? 1 and 10, 2 and 5. Is there a 3 in something? 4, 5. Oh, yes, 5 and 2. 6, 7, 8, 9, 10, 10, and 1. Okay, there are no more factors. I've exhausted all of my whole number factors for 10. So now I need to make sure that I put a minus in front of each one because I need to figure out when I add these together, remember integer addition, when I add them together, my goal is to get a negative 11 for my middle term. So negative 1 plus negative 10 gives me negative 11. Negative 2 plus negative 5 gives me negative 7. Negative 5 plus negative 2 gives me negative 7. Negative 10 plus negative 1 gives me negative 11. So of the options that I have, I can choose this combination or this combination. It doesn't matter. So I can just put 10 and 1 right there. But remember, with slip and slide, what I need to do is to slip my original coefficient underneath each one of my constants. Simplify, so I can simplify, and this becomes n minus 10 times the quantity n minus 1, and that is my final answer, right? All right, so that one is cool. Well, what happens if I have a coefficient that has something other than 1? So now I have a situation. Now in this situation, I have a coefficient that's something other than 1, right? So I'm going to go back and let's check this out and see what happens. All right. So with this situation, I have a 2 in the front, a 6, and I have a 108. The first thing I want to do is check for a greatest common factor. All of these can be divided by 2. So 2 divided by 2 gives me 1. So I'm going to factor out a 2, and I'm left with n squared plus 3n minus 54. Okay? All right. Now, I'm going to leave this alone for a second. And what I'm going to do is I'm going to write my 2 parentheses. I know that this coefficient is 1, so I'm going to leave this 2. Let's just put a box around that 2 for now. All right. And I'm going to factor this right here. Now, I have a little situation. Notice that my constant has a minus in front of it. Remember, this tells me whether my signs are going to be the same or different. If this is a negative, my signs are going to be different. So I can go ahead and put a plus and a minus. Right now, it doesn't matter where I put my plus. It doesn't matter where I put my minus, as long as I put a plus and a minus, because my signs are different, right? All right, so now I need to take a look at this middle sign. This middle sign is always going to be the sign of the largest integer. Okay? So, and we're talking about the integers in terms of absolute value. Okay? So, I need to write down all of my factors of 54. So let me go over to the side. 54. I have 1 and 54. I have 2 and 27. I have 3 and 18. I have 4 and nothing. I have 5. Let's see, can 54 be divided by 5? No, and remember, we want whole numbers. So make sure that you have your calculators out, because you want to make sure that you're dividing and finding all the factors of 54 that are whole numbers. All right, so we don't have 5. What about 6? We got 6 and 9. What about 7? 54 divided by 7? No. 54 divided by 8? No. 54 divided by 9? Yes. So now we're back to 9 and 6. And then, of course, it's going to repeat itself, right? So now, remember what I said over here. My largest number is going to be positive. So I'm going to put a plus on all the big numbers. Right? And I'm going to attach a minus to all of the smaller numbers, right? Looks like I have Christmas colors here. All right, now we're going to do something Remember your integer rules. So remember, when you have integers that have different signs, one is positive, one is negative, you're going to subtract those numbers and take the sign of the larger number. All right, so let's take a look. 54 minus 1 is going to give us 53. Now remember, our goal is to get a positive 3. So we're going to look at all of these and see which one of these combinations is going to give us a positive 3. 27 minus 2, 27 minus 2 gives us 25. 18 minus 3 gives us 16. Negative 6 plus 9 gives us a positive 3. Positive 9 minus 6 gives us a positive 3. All right, so right now you should be able to tell which combination works. So let's take a look at all of our options and find out which combinations work. Well, how about this? So here we're going to place a positive 9 and a negative 6. Don't forget about this 2. Now we factored out a 2. That 2 comes down with the answer, right? But remember, we did the little slip and slide things, and we had a 1 in front of this, n squared. So I'm going to divide this by 1, and each one of these is simplified. N plus 9 and n minus 6. Bring down my 2, and I have now factored completely. All right, now this is a problem where we're going to do slip and slide again, but this one you'll see the full effect of slip and slide. All right, so if we take a close look, we notice that we have a coefficient of 3, negative 2 in our middle term, and negative 5, right? It's in descending order, so we're good with that. This leading coefficient is something other than 1. So we're going to start with our slip and slide process, where we take this leading coefficient and multiply it times this constant in the back. So we're going to rewrite, and we have p squared minus 2p minus 15, right? Now, because we have a trinomial, we know that it's going to factor into two binomials. So I'm going to go ahead and write down my p's, and I'm going to take a look at my signs. This sign tells me that my signs are going to be different. So this is different. That means that they're going to be different from each other. And then this sign tells me this is going to be the sign of my largest integer, right? So I can go ahead and put a plus and a minus because I know that they're going to be different. But now I'm going to go over to the right side, and what I'm going to do is I'm going to write down all of my factors of 15, right? Because this is what I'm working with right now. So I'm going to write down my factors of 15, and I'm going to start with 1. I have 1 and 15. Does 2 go into 15? No. 3 goes into 15. 4, 5 goes into 15. 6, 7, 8, 9, 10. We can go all the way back to 15 and 1. Now remember, this sign in the middle is the sign of my largest number. So every number that is big over here, I'm going to make it negative, 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 and negative. All right, now I need to do some addition. So I'm going to add all of these up, and what my goal is to make sure that everything adds up to, or whatever I get, I want to get a negative 2. So 1 minus 15 gives me negative 14. 3 minus 5 gives me negative 2. Negative 5 plus 3 gives me a negative 2. And then negative 15 plus 1 gives me a negative 14. All right, so I'm clear on what combination works. It is here. So what I need to do is I need to put a negative 5 and a positive 3. But I'm not done yet. This is where slip and slide gets really good. Pay close attention. I now need to take my coefficient that I multiplied, and I need to bring this down underneath each one of my constants, right? I want to simplify where I can, so that means I need to reduce where I can, okay? So I am going to reduce this 3 over 3, that becomes 1, so p plus 1, times the quantity. Now negative 5 over 3 cannot simplify into a whole number. So this is where the slide comes in. So what I'm going to do is I am going to take this 3 and slide it in front of that p, right? So now my final factor is 3p minus 5. And this is your completely factored trinomial. All right, not bad, huh? Now right here, we're going to take a pause, and I want you to type in the chat or in the comments if you have any questions or concerns thus far, and I will be sure to come back and check those questions and address those questions in the next video. All right, let's go to the next problem really quickly. All right, and you can verify this. You can verify this by multiplying it out. Okay. All right, we have another one. Let's do this one. We have a coefficient of 2, a middle coefficient of 3, and a negative 9. All right, we don't have a greatest common factor, so I'm going to do this multiplying this coefficient by this 9, and I'm left with n squared plus 3n minus 18, because 9 times 2 is 18, right? All right, so now I have an 18. I'm going to write down my 2 parentheses. I'm going to factor my n squared, that's n and n. Now I'm going to take a look at my last sign, that's a negative, right? So that tells me that my signs are going to be different from one another. So one is going to be a plus, one is going to be a minus, and my goal is to have a positive 3 in the middle. This tells me that this is the sign of my largest integer. So I'm going to go ahead and write down my factors of 18. I have 1 and 18, 2 and 9, 3 and 6. Is there a 4? No. 5? No. 6 and 3. So I'm going back around so I can stop right there. Now remember, this plus tells me that my largest number is going to be a plus. So I'm going to put a plus here, I'm going to put a plus here, a plus here, and then a plus here. All right. And I know that my other sign is going to be negative. So I'm going to make that negative, negative, and negative. And I know that when with integer addition, when I add two numbers where one is positive and one is negative, I'm actually subtracting and taking the sign of the larger number. So negative 1 plus 18 gives me positive 17. Negative 2 and positive 9 gives me a positive 7. Negative 3 and positive 6 gives me a positive 3. Now, which one of these combinations works? Well, guess what? We already know our goal is to get a positive 3, so this combination is what works. So I'm going to put a positive 6 here, and I'm going to put a negative 3 here, right? But I'm not done yet because I have to bring this 2 back into the problem. The way I bring the 2 back into the problem is I make it a denominator underneath each one of my constants. I simplify where I can. The only thing I can simplify is this 6 over 2, which simplifies to 3. So I have n plus 3, that's the quantity n plus 3, times, now this does not simplify. So I need to slide my 2 in front of this n. So now I have 2n minus 3. And this is my simplified answer. Now, hopefully I have made factoring trinomials a little easier for you. I know when I was in high school, we did the guess and check thing, and that just threw me all the way off. But this works if you have a trinomial of degree 2, and if you have a coefficient, a leading coefficient of 1 or anything higher than 1. All right, so hopefully that was helpful. Again, please leave your questions in the comment section. Like and share if you know somebody who is having difficulty with factoring trinomials. And I look forward to seeing you in the next video.